Okay, my friends, another shocker du jour. I put this up the other day about Devil's Tower and how it is biological and what is really constructed of. And I thought, people would watch the video. They didn't watch the video. Within 10 seconds of having the video up, I must have had a half a dozen people say, "You're an idiot, that's a tree." Well, it's a foot, and it is biologically very, very obvious. Now, this right here is, I believe this is a hip joint, and this is the tendon that attaches to the bone of the hip. I'm going to show you one in an anatomical drawing in a second. This is the glue that literally glues tendon to bone. You don't see it in Devil's Tower, but you do see it in Finigals Cave, and you see also the same tendons in Finigals Cave, and the Giants Causeway, everywhere. But what I want you to see is here in the microscope in a second. We're going to look at this spot right here, where this little piece of a tendon attaches to the bone and then attaches to the muscle, runs down the leg. All right, with very few exceptions, tendons attach to some bone, and then they run out a little short distance, and then they attach to muscle. And that's what you have here in the femur. And I believe that's what we're looking at on my bench. All right, again, I believe this is where the femur attached to the body. And then this is the glue right here. We're going to be looking at this glue and then Finigals Cave. And this is that short segment of tendon, and then it runs into muscle. We're going to be looking at this in a microscope. You're going to be able to see it. It's extremely obvious. Okay, you're in for a shock. I can guarantee you that. That was, I believe, the Okay, my friends, you are in for a shock, guaranteed. This is Welcome to Mon-Ira's vlog. I'll show you more detail about her in a moment and her fabulous job she did showing Finigals Cave. Now, we know it all has these fibers, and it has all this gnarly looking stuff at the top. What the hell is that all about? Well, I claim they're tendons, as I could claim so is Devil's Tower. However, this tendon ran up to a bone ball that sat right here and attached literally just like this. All those tendons attached to a bone, exactly like they do here. You see this? These are the same tendons. We're going to look at the microscope. You won't see any difference. This is the same glue that is this glue that would have attached it to this bone ball. Let's look at some anatomy. So don't forget, this is Mon-Ira's vlog from the UK, and it's Finigals Cave, world's most popular sea cave, Isle of Staffa, Scotland. Now, I say this bone ball right up here is nothing more than this bone cradle right here, because the bone is gone. Bones did not last in the saltwater floods where they were continuously bombarded by salty waters. They just disintegrate. So what happened, it left the glue. This is the glue. This is literally glue, and it's just this gnarly, nasty looking, and that was what holds it to the bone. Otherwise the tendon ripped right out of there. And this is the tendon itself, and that's these fibers. And I will show you those fibers. You can actually see them if you get it in the right light with this, but you can see them absolutely perfectly with a microscope. So that's my contention, is that we have a bone. Let's come back out of here, which is eroded away up there, which is this bone. We have this gluey looking stuff, which is this gluey stuff, and then we have this tendon fiber, which is this tendon fiber, and then it runs down to this muscle, which attaches to the tendon. I'm going to show you all that anatomical. This is not hard to understand. This is the hip joint. That's the hip. That was standing up. That's the hip joint is eroded away, and all the rest of his body's gone. But the tendon running down here is still attached in that one little gluey spot. That's why, if looking down on it, you can see that that's what happened there. That's why that one little attachment spot coming down is still there, because of its toughness. All right, I mentioned at some point that all these tree screamers, the first thing, they never watch anything and immediately start screaming about trees instead of being what they are is the feet and the tendons and all of the different biological body parts and anatomical things that I show. Now, this is the reason they're not trees. Dissolution of cellulose, direct dissolution of cellulose. Well, how does that happen? The most successful way, one of the most successful routes to dissolving and shaping cellulose into like liquids is via the viscous process. This technique involves conversion of cellulose to cellulose xanthogenate by a reaction with carbon disulfide in sodium hydroxide. Well, what's carbon disulfide? Well, it's carbon and sulfur basically in salty, basically water. OH is, H2O is water. OH is very damn close. It's an ion. And this is what happened. It destroyed the trees. They're gone. They dissolved. All right, before we get too deep into this, because we're going to get in with the microscope, we're going to be looking at a lot of anatomy, and I work with some of the top anatomists in the world that understand fascia and tendons and all. There's a ton of different connective tissues in the body. Everywhere in your body, it's a different type of connective tissue. Not necessarily, but there's tons of different styles and attachments and emplacements. And the Achilles tendon is very long and tight and strong and taut. And when it breaks in an abrupt transition. You get all these wrinkles. Other tendons do different things because they're in different parts of the body, and they're not these big extended ones, they're little short ones. And anyway, we're going to get into all this deeply. All right, the more I look at this, I'm almost certain that is the hip. I believe it's the hip. And right there is the rotation where you can go, you see all the tendons running into here and gluing, and then there was a stalk right in the middle, which was a rotation point. So you can go this way, this way, this way, this way, all that stuff from this bone ball, basically. And that is the glue. That's the glue we're going to be really looking at close. And then the weave of the tendon into the weave of the muscle. You see that little weave right there? I don't know if you can see that or not. But see that? I don't know, well, it's going to be hard to see. They weave right into each other, and they glue right together, and the strips, the actual straps of them and everything, absolutely stunning. And this is, I talk about the sandy area out tough skin is on the outside. There it is right there. And then you run into the bloody area. When I put some water on this, it'll all show up very nicely. And then you get down into the flesh. That's the way your body works. The way your body works. All right, all right, as I said, there's tendons all over your body, and some of them are quite different, and some of them are very similar. This is quite different than the Achilles tendon, which is that entirely long, straight, tough tendon. When it snaps, boing, there's a ton of tension here. All right, where you're seeing here, everywhere you see white hitting the dark is tendons, abrupt transitions. And somewhere over here is the hip area, which is, I believe, what I'm showing you, and which I believe is what Finigals Cave is. He was standing up, died, and everything else eroded above him. All right, I believe this is exactly where Finigals Cave is, and everything above has eroded and gone. And there was a ball right there that sat in that cavity that I will show you, or have shown you, where the glue literally glued to it. Just like the glue I'm showing you on my specimen in my shop. All right, all tendons have abrupt transitions. This is the finger of a human being. Right there is an abrupt transition where it goes into the muscle. You see this big flat strap right there? See that big flat strap? There's a bone underneath there, the bone ball. That's the same one over there. Can you see that? Yes. All right, so this flat strap runs across. The tendon runs over to a muscle, which allows your finger to do this. Well, guess what? This right here is exactly this spot right here. All right, now watch. That's the bone ball. You see there's a bone ball here? That flat strap is this flat strap. You see this right here? That's this. It's abrupt transition, and it is abrupt. You see right there? See, I want to try to get it in a right light where you can see. You see that little spot in the center? That's where it turned into muscle. That's the abrupt transition. And this is the muscle right here that is the same muscle that wraps around the bone balls. You see it? One side is eroded right down to the bone. And you see underneath, see, this was laying like this flat. That's why this is flat. All my stuff is flat on one side, and I have the whole hand from this, and I have fingers, and I got all kinds of things from this. And that is that right there. This is exactly the spot. And that is what they call, or what I call anyway, an abrupt transition. We'll look at it in the microscope and see if we can see any really good articulation in there. But that's what happens when the white stuff runs into the red stuff. Just like somebody chopped it with a knife. So there's the Achilles tendon. They don't break the same way other ones break at the abrupt transition. They break right down here. This is the stress point. There's a lot of flex to this. And they break right there. And it's still an abrupt transition, just exactly straight across. And it happens every single time the same way. And that's where you see all these hex fibers. Alright, just a very quickie, just to show you this. They run down all these tiny little fibers. There's a bazillion of them. And so it gets smaller and smaller and smaller inside each one of these little bundles. Each one of these bundles turns into one of these bundles, turns into one of these bundles, turns into one of these bundles. And at the very end, they go into balls. These collagen fibrils and so forth. Now, this is where normally the emphasis is, where the bone attachment is. There's other styles. And this is, of course, the abrupt transition right between where, like I'm showing you on my fingertip. You see that? Yes, you can. Now, I think this also was a hip attachment with the femur running down. And it could, you know, that's, you see this? It's like a joint. You can go this way, that way, that way. Very cool. And, of course, all the fleshy stuff eroded away. And in this case, I don't see any tendon attachments, or they broke right there. Just another quick shot. There's all kind of different attachments, to ligaments, to regular tendons, and then there's ones that attach to your abdominal muscles and so forth, flat ones. Now these balls are all over the world, and they're gigantic because the creatures were gigantic. And they have these enthesis tabs sticking out of them, and they break right off there. So you have a little tiny indentation, and then you have the ball. And then inside of them, sometimes they have structures inside like a lattice, sometimes they're like eggshells, all kind of different styles. And I think some of them may be able to distort a little bit, and some of them are made to not change shape whatsoever. Alright, you see this? These straps running across attached to this mat. That mat is a tendon, very tough. And it lays flat on surfaces in your body. I think, abdominal and so forth. It has to be able to give and come back and give and come back. These little fibers go right through a hole. You see it through a hole? And they attach to a ball. And that ball is supposed to be into that hole right there. All right, well, it pulled out of that hole. That's an injury. These are probably still attached. But you see how there's all across there? The bumps in the walls down in Peru are from these attachments. They just broke them off. And they used, this was all used moist stuff at the end of this flood. They came back and used all the dead bodies, it looks like to me. Now I have the same thing here. This one here is one of those balls. And this is another one that sat right on top of it, just like this. Whoops. It could slide back and forth on top, just like these here do. So this would be like laying this way, this one laying on top of this one. Similar to this. Alright, and all these little white fibers are tough as hell. And you see that white rind? I call it a rind. That's the fascia around it. Everything has its own fascia. And then in between, this is called slurpy, small leucine-rich proteins. They slide back and forth. Everything has to be able to slide smoothly. Synovial sheath, synovial fluid, very, very slippery stuff. All right, this is somewhere in Iceland, I'm not sure where, but this is actually red blood. That's iron oxides are blood. That's iron oxides. You see this? There was a blood supply running through here. Everything has to be serviced with blood to some degree. Tendon, very little actually, but you're going to have an artery running through there somewhere. And it's going to branch off into little tiny, tiny blood vessels to feed cells. You know, these are tough stuff. They don't need a lot of attention, basically. They're just hard, strappy connective tissue. All right, it really is absolutely phenomenal. This is collagen fibers, all right? These are nanometers, 1.5 nanometers. All right, well, hold on. All right, the size of the creatures just, I can't account for how they lived or what happened, but I mean, they were wiped out, and I think it was definitely by the flood. Now look at this. These are collagen fibrils. You run it down to this little spot right here is the same as this tiny little spot. You take that tiny spot over there, it's just one tip, and it has all these little fibers inside. You look at that, one little tip, it's one of these in the fasciae, which is the fascia. All right, now you look from this over to here, and this is what the tendon looks like. You see all these little, tiny little fibrils? That's what the stuff that we're seeing on Devil's Tower and all these other places is these tiny little fibrils. Now, what else do we see? We see different types of tendinous fibers. Some of them have little breaks in them. Some of them are like this. And some of them are all wavy like that. And I show all of the types. And they're everywhere on Earth, so you can't, like even right here, this has all the same sort of stuff. These are tendons here too. And we're going to look at it in a microscope. I don't know if you'll see it close enough like you see it here, because this is like, these are nanometers. This is micrometers. All right, that's, I think it's like 25 thousandths of an inch is a micrometer. These are just tiny, tiny little things. All right, so again, these are the fibrils, absolutely incredible. And these are the different formations of the fibrils. Some of them are wavy, you know, and I think this is probably an abrupt transition or something. Well, all right, we're going to see all these different styles of formation in different areas of different tendons because they attach to different places, they do different jobs, they have different stretch dimensions and all that stuff. In your rotator cuffs, totally different than in your Achilles tendon and so forth. I mean, it's just so obvious it has to be looked at a little closer. And again, I work with some of the top anatomists in the world. They do biopsies all the time and, you know, anatomical autopsies, and that's what they're into, is the fascia. And it's mostly for sports injuries and so forth, because that's where people are being injured, where their tendons attach, and I hooked up to a lot of these people years ago when they were just getting into rolfing and different means of working that fascia to make it pliable again. Now everything's physical therapy, and that's what it's based around, is making that fascia move easily and freely. Otherwise, like one of my friends that is an anatomist, he says when he does an autopsy, he can tell if the guy had back pain or not by how free the fascia is running up his back. If he can just pry it open with his fingers, he just goes like this, and the fascia separates, the guy is very mobile. If he's got to cut it with the scalpel, he knows that guy gets up and he can't hardly move. He's just locked up. Okay, I normally don't get this deep with anybody except my very deep anatomy friends. This is a tendon, all right? The whole thing is a tendon. Now, it breaks into other segments. Now, there's a wrapping, a coating around a tendon. They call it the epitendon. Epitenon. All right, now, it's actually the immunotendon, because this is where the enzymes collect to protect everybody that's inside. Now they also have their own, but they call them endotendon. Now I don't think there's any more enzymes in here and here and here and down to the end, because once you protect yourself here on the furthest out one, you're good to go, because that wraps everything together. If it gets into here, these guys got to come back down and fix you. That's the biological part of it. But what we're looking at here is the same thing here. You see what I'm showing here? You see those little dots all over there? That's those little dots right there. Exact same thing. Basically exactly the same thing. Now, this, although this is a different style of tendon, this comes all the way down to all these different bundles. This is a flat tendon that's on your stomach. I think I showed this some other places. And this slides back and forth, that type of thing. And you have a whole batch of them together. But this is the epitendon on this. I thought I put catalase in here looking for the enzyme, and it didn't happen. I said, oh, something's wrong. But then I put it on the outside, and popped right up. So this is the one protective layer, and then inside that, no more enzymes. You don't need them. Once you're protected out here, you're good to go. But this is where we are. I'm not sure where we are with Devil's Tower, but it's down in this area somewhere. It could be here. I don't know. But this stuff here is the little slurpy stuff that's all wrinkled up on the side of these tendons. It wraps them. It's a wrapping. It's just like a plastic bag coating them. See, they all have them. And by the time they hit the end, there's a ball. And that ball locks to the end of these fibers so the fiber can't pull out of the position that it's in, which is the anchor. You see this? At the end of every one of these fibers, they come down like this and they wrap around inside of a ball. And that ball anchors, and these fibers can pull. They can only stretch just a tiny little bit. These are very, very, very tough. Very tough. But this is how they anchor inside of the bone or whatever. Okay, and we're going to discuss the new anatomical part that I have discovered, which I'm going to name the spurlock. And what is this? This is it right here. What is this? This is it right here on a rock. Now, what do they do? They anchor meat into other meat. In other words, your shoulder into your body, your leg into your hip, and all that stuff. They anchor chunks of muscle together. They anchor even lungs and organs so that they can move around, but they come back. That's the spurlock. It pulls and stretches and does all these kind of things. And here's a lung that has a spurlock right on it right there. You see, everything was biological at one time. There's the lung. Here's where the entrance to the lung is. All of these little tiny dots were the alveoli of this little tiny lung. I don't know, like I say, I don't know what it was from, but they all have that latch, the spurlock. Otherwise, this thing would float around upside down inside your body, you know what I mean? That's what these are all about. And I have a meteorite came through space, a lung, and it has the same thing, it has a spurlock on it. Space loaded with biology, and they know this now. Just look up what's loaded in the solar wind. It's 100% chemistry of blood. All the astronauts say they go out on a spacewalk, and when they come back in, their suits smell like sirloin. All right, so what have we learned? We learned that there's a lot of different types of tendons. We learned that Finigals Cave is the gluey stuff at the top with the tendons running down into the muscle that was down inside the ocean, and up above the bone ball eroded away. That's, I say, what Finigals Cave is. And some of these holes, you see these little tiny holes here? We're going to see this in a microscope. You see those little holes? Those are the caves. Those are the caves running through, because that's where the blood ran through. All right, and that was the bone, and that was, I mean, it's really coming quite obvious now what's going on there. And as you see this I decided to do this in two parts because it's running long here, and I know people don't have much time. So we will get back to this, and we're going to be looking at this deeply in the microscope. We're going to be comparing it to tissues that are completely, totally understood, but not in the deep level that I'm at. Because normally you can't see these things in living tissue. You're not going to see it. It has to be preserved in this manner to be able to get down here and see these things actually as they were when they were alive. That's the only way it can be done. That's the only way it can be done. You can't. Otherwise, it really gets gushy. I work with all these people. I understand. They understand too. And nobody's pushing back. Trust me. Okay, this just came out in 2018. Meet your interstitium, a newfound organ. And this is basically what we're talking about. Is right below the mucosa is this layer right here. This really red line is actually, I call that the immunothelium, because that's where the catalase and all the enzymes wait to attack invaders. That's where they as they call it, a fluid-filled highway, and it is, because those little buggers can go 1,000,000 miles an hour. They have a flagella on them, these little bacteria. It spins 100,000 RPMs, and this is a fluid-filled highway. That's why you take some kind of drug or something, it gets in your system instantly. Now they're giving a monkeypox right into that fluid-filled highway, and zip, it goes all the way around your body very quickly and efficiently, rather than being deep in here and trying to get back out to get into that. Because that's the layer that has to protect you. This is where you want to be protected. That's where your immune system lives. Anyway, I saw this 10, 12 years ago. And again, I tell you, I've been working with some people that know people. I don't know this guy here that did this, but this is the interstitium, and there's the balls and so forth. And this all falls into exactly my research. I saw this years ago. And they say the only reason they never saw this before, because they've never been able to look at this in the way I look at it. They always looked at it in a slide. Somewhere up here it says, hold on. All right, here was the issue. They were looking at it in slide microscopes, which I have. I don't use it anymore because I use a microscope where I can see in extreme detail in its completeness. And this is what they ended up doing. It says the researchers said the fluids-filled spaces, all this stuff, they got crushed. They had been missed for decades because they don't show up on a standard microscopic slide. Researchers used to peer into the cellular world. They look flat and they shine light through it, and they see little things in there, and when scientists prepare tissue samples for these slides, they treat the sample with chemicals first of all. Then they cut them into extremely thin slices, dye them so that they can see the different things in there. Then they highlight them with light underneath so they can see those features. But this fixing process drains away fluid, causes the newly found fluid-filled spaces to collapse. So all they see is a background image. So rather than using such slides, the researchers discovered these fluid-filled spaces by using a new imaging technique. Allows them to examine living tissue on a microscopic level. That's right. This is it right here. This is the. Can you see that? This is a telescopic microscope, and I can see. I don't have to see living tissue. I can see it preserved as if it was literally alive and not gooey. So they finally figured this out not too long ago. But like I say, I've been working with a fellow for 10 years, Gil Headley, who is, as far as I'm concerned, he's one of the top anatomists in the world. Extremely curious about, he worked with me, and a lot of people refused. And we still talk. He doesn't commit to anything. I'm not putting any words in his mouth, but as far as I know, he hasn't disputed anything I've said. He hasn't necessarily said it means what I say it means, but he's that looks like what you're saying it looks like. He knows, and he's an anatomist and very, very skilled. So, and these things, well, here, hold on a second. I'll show you how big they get. And that's the key. This is what drives everybody away. That it thinks they're in the mainstream and they're scared to be attacked. That's just the truth. I've been attacked for so long that attacks are just part of my life. Alright, these are all the interstitium balls, you see them? And this is the mucosa on top, laying on it this way. Let me show you something, how big that gets. Alright, this is what an artist's rendition of the mucosa, I'm sorry, the interstitium is. This is the mucosa. Then you get down to the interstitium. We have all those little balls, and the balls are tough as hell, and they're anchors. This is very erodible because it's just wet, fleshy stuff. And guess how big it gets? Look at this. Look at that. That's in the United Kingdom somewhere. Huntington's Beach or somewhere like that. Now you see that very, very red layer right there? That's the immunothelium. It's where all the enzymes collect. But below that is all that interstitium balls and all that stuff right there. Above that is the mucosa. But this layer right here, that's the fluid-filled highway that carries all the bacterial enzymes. And the bacteria run through here like 1,000,000 miles an hour. I think I mentioned before, they have flagella. They spin 100,000 times a minute. Zoom, they go flying down, and they have enzymes with them. And the enzymes have catalysts, and the catalysts are elegant chemistry that attack or dissolve food coming through so you can absorb it. And there's a ton of stuff going on here, but my point being is look at the size. Look at the size. These balls were in these walls, and now the balls ain't in the walls. And this mud was part of this wall before, and it just eroded away. It turns into the mud we see everywhere. It's time we really pay attention to what's sticking us right in the face. All right, that's a bone implant. This is a structure coming off it that attaches to the tendon, attaches to the muscle. I'm going to show this in such great detail, nobody can deny it. Alright, I'm going to leave it at this for today, but I'm going to go deep into this. I got the microscope fired up. I'm fired up. I had 2 cups of coffee today. Now, if you want to get into if I would like to have this broadly broadcast, I need somebody that's media savvy that wants to help put this out or do something with it. This is how you get a hold of me. Email gsrgroup10@gmail.com. Twitter is @gsrgroup10. That's it. Thank you. I love you all. Stay tuned. I am going to get so deep into this. I mean, it's shocking stuff. Absolutely. And people say, ooh, jarring people. Well, yeah. What do you want me to do? Run away and hide? I can't. I'm done with that. I need to confront now, and I need people to have to stand up for themselves and say, no, Roger, you're wrong, or yes, Roger, we'll take a look at it. Once you take a look at it, there's no denying it. That's the problem. They refuse to look, because once you look, you can't help but see. Either that or just, as far as I'm concerned, I just can't imagine you not being able to see the things I'm showing. It's just impossible.